Hello everyone, welcome to Vijay Chemistry channel. Uh, Thank you for your positive feedback, your continuous likes and shares. It will give more responsibility to do more effective videos. Today we are going to discuss its continuation matter in our surrounding. Previous videos we completed till the physical states of matter. That continuation can matter change its physical state? Can matter change its physical state? One question mark. Means, is it possible to change its states of matter? Solid to liquid, liquid to gas? If it is possible, what factors are affecting on it? This we are going to discuss today's video. Yes, to prove that matter can change, to prove that we are going to discuss an activity. Take a beaker with ice cubes. That beaker, put it on Bunsen burner and thermometer fixed to the stand and insert in the beaker. The thermometer edge should touch the surface of the ice cubes. Don't insert in ice cubes, just touch the surface of the ice cubes. Now, what happened? We are going to discuss. Ice cube means it is in solid state. As per previous knowledge, ice cube means it is in solid state. Solid state means between the particles, attraction is more, interstitial space is less. Means gap is very less. When attraction is more, gap is very less. So as per that exists as a solid state. Now, can matter change its physical state? That is our question. So, with the help of a Bunsen burner, we are giving heat. When we are transferring heat, that heat transfer through the beaker and absorbed by ice cubes. Slowly, ice cubes absorbing heat from bottom of the ice cubes. The heat is transferring slowly all the molecules until heat transfer to every molecule which is there on surface. Until that, we cannot notice any heat changes in the thermometer. Means we are giving heat from bottom, so every molecule getting heat and transferring to others, absorbing heat. When it reaches the surface of molecule, when all the molecules get equal heat, then the heat is transferring. The heat is we are noticing in the thermometer. So, in this activity, what we are going to observe is solid converting into liquid. The process of conversion of solid into liquid. Solid into liquid. What is meant by conversion of solid into liquid? What we used to call means that is we call melting. Ice cubes are melting by absorbing heat. So the process of melting. What is meant by melting? The process of conversion of solid into liquid are called melting. Okay. Okay, melting means solid to liquid. What is meant by melting point? What is meant by melting point? Melting means everyone understood now. What is meant by melting point? Melting point. So here, generally ice cubes means that may exist below 0 degree Celsius. Means at low temperature. Ice cubes are exist. So when we are giving heat until get all the molecules equal amount of heat, equal heat, equally distribution to every molecule, then only we notice in thermometer heat is increased, temperature is increased in the thermometer. That means once melting point started means that particular temperature we are noticing in the thermometer 0 degree Celsius. So once every molecule reached to 0 degree Celsius, from below 0 degree to 0 degree Celsius, the surface of the water molecules started to melt. Along with that, every molecule continuously converting into liquid form. So the particular temperature we used to call melting point. Okay, the temperature at which solid converting into liquid, that temperature are called melting point. The temperature at which solid converting into liquid at atmospheric pressure. At atmospheric pressure. Pressure are called melting point. The temperature, at what temperature the process solid converting into liquid, that temperature we are calling melting point. Generally, ice melting point, it occurs at 0 degree Celsius. So, ice melting point of ice is melting point of ice is 0 degree Celsius or 273 kelvins. 273 kelvins. Exact value 273.15 kelvins. There are different scales: thermometer, Celsius scale, Kelvin scale, Fahrenheit scale. About scales also we will discuss separate one video. Today we are going to discuss in this way. So, can matter change its state? Yes. Through this activity, we are going matter can change its physical state, solid to liquid. Yes. Once again, I'll give briefing. First, we taken ice cubes in a beaker, and that beaker we kept on Bunsen burner. Through Bunsen burner, we are giving heat to that. Before that, we place a thermometer on surface of the ice cubes. Now, when we are continuously giving heat, while giving heat, we cannot notice any observation, we cannot notice any rising temperature in the thermometer because we are giving heat from bottom. Every molecule getting transferring heat from one molecule to another molecule in ice cube. Once the heat is reached to the surface of the ice cubes. That means every molecule having equal amount of heat there. Then we notice in the thermometer rising temperature from below 0 degree Celsius to 0 degree Celsius. So once it reaches the 0 degree Celsius, the complete ice cubes converting into liquid form. Okay, through this activity we learned solid conversion to liquid. That is we call melting. At particular temperature, at what temperature the melting occurs, that is we call melting point. Okay, melting point of ice 0 degree Celsius or 273.15 kelvins. Next, now solid completely converted to liquid. At the time we notice the temperature in the thermometer 0 degree Celsius, means solid to liquid conversion happens at 0 degree Celsius, ice to liquid. Okay, so that is the melting point of ice. Now after melting, still we are continuously giving heat. After melting, still we are continuously giving heat. The next further process, same like previous what we discussed, like that only. Once we are continuously giving heat, again every molecule raising the heat itself and transferring into another, and when it reaches the every molecule heat equal to all the surface molecule, rising heat from bottom to surface. At the time from bottom whatever the heat are there, same heat when it becomes to the surface of the molecules, at the time whatever thermometer, again it will start to rise the temperature. Again it will start to rise the temperature. So once temperature rise to 100 degrees Celsius, at the time we notice here the water started to evaporate. The water started to evaporate. That means initially solid converted to liquid at 0 degree Celsius, that is we call melting point. Once the heat is reached to 100 degrees Celsius, the surface of the molecule started to evaporate. That means at 100 degrees Celsius, water having boiling point, that is we call boiling. When it reaches to 100 degrees Celsius, that is we call it boiling. So first, here what happening means liquid converted to vapors. Liquid converted to vapors. Liquid converted to vapors. So the process of conversion of liquid into vapors are called boiling. Boiling is nothing but the process of conversion of liquid into vapors. The process of conversion of liquid into vapors are called boiling. What is meant by boiling point? Freezing means solid to liquid. Freezing point means the temperature at which solid converted to liquid. That is we call freezing point. Same here. Boiling means the process of conversion of liquid into vapors are called boiling. At which temperature this process occurred, that is we call boiling point. Okay. So boiling point . boiling point. The temperature at which liquid converted to vapors. Liquid converted to vapors at atmospheric pressure. At atmospheric pressure are called boiling point. So what we notice here, liquid started to convert into vapors at 100 degrees Celsius. Here initially we taken water in the form of ice cube. So ice cube converted to liquid at 0 degrees Celsius, that is we call melting point. Now continuously we given heat, that heat reached to the 100 degrees Celsius. But until get every molecule 100 degrees Celsius, you cannot notice any rising temperature in the thermometer. Once the surface of the molecules reach to 100 degrees Celsius, then from 0 to 100 degrees Celsius, thermometer will show the temperature rising. So that particular temperature we used to call boiling point of water. Okay. So what is the boiling point of water? Boiling point of water is 100 degrees Celsius or 373, exact value 373.15 kelvins. Generally, everywhere we used to take round of value, it is just 373 kelvins. Okay, I am writing here exact value only because melting point we taken 0 degrees Celsius or 273.15 kelvins. So that 15 also after decimal I am using here, or 373.15 kelvins. 373.15 kelvins. Boiling point of water. So now all of you got to know melting point of ice is 0 degrees Celsius or 273.15 kelvins. Boiling point of water is 100 degrees Celsius or 373.15 kelvins. Here conversions Celsius scale to Kelvin scale. That is what I given. So next video will get it about conversions also, one class. No problem. Here while converting solid to liquid or liquid to vapors, we noticed one thing. What is that means? Until reach, even though we are giving continuous heat, until reach the particular melting point or boiling point, we did not notice any rising temperature in the thermometer. Means what we are supplying heat from starting until the reaching melting point or boiling point, that all at a hidden heat. Hidden heat. That is what we are calling latent heat. Okay? Hidden means latent heat. Yes. Latent heat. What is meant by latent heat? Latent heat is meaning is hidden heat. Hidden heat means whatever we are giving heat, that heat is transferring through the molecule to molecule, but that all we not notice with the thermometer. Once that all heat reach to the surface of the molecules, then only we are noticing in the thermometer. So until that, that heat, whatever we transferred, absorbed by molecule, and that between the molecules, whatever the force of attractions are there, that becomes weaker. That is what it is able to transfer from solid to liquid, liquid to vapors. Okay, so latent heat is nothing but hidden heat. Hidden. Latent means hidden. Okay, now what is meant by latent heat? The minimum heat energy required. The minimum heat energy required to convert 1 kg solid into liquid or 1 kg liquid into vapors. That is we call latent heat. Okay, so first latent heat, giving definition. The minimum amount of heat energy the minimum amount of heat energy required to convert 1 kg solid into liquid or liquid into vapors. That is we call latent heat. If a solid into liquid, that is we call latent heat of fusion. If solid liquid into vapors, that is we call latent heat of vaporization. Okay, so simply latent heat means the minimum amount of heat energy required to convert 1 kg physical state into another physical state. Like that also correct. Latent heat of fusion. Latent heat of fusion. Fusion means melting. Latent heat of fusion. Okay. What is meant by latent heat of fusion? Same definition. The minimum amount of heat energy required to convert fusible means melting. Which is melting? Solid. Solid converting into liquid. So the minimum amount of heat energy required heat energy required to convert 1 kg solid into 1 kg solid into liquid. Liquid at atmospheric pressure are called latent heat of fusion. Next, latent heat of vaporization. What is meant by latent heat of vaporization? Same definition. One small change. Latent heat of vaporization What is the small change means? Same definition. The minimum amount of heat energy required to convert 1 kg solid into liquid means fusion. Liquid into vapors. 1 kg of this, only this area I am going to change. So directly I am writing that 1 kg of the minimum amount of heat energy require to convert 1 kilogram liquid into vapors. Liquid into vapors are called latent heat of vaporization. Children, today we discussed melting and boiling and latent heat. So if you observe this all, to make it convert, what factor affected on this means here temperature, heat transferred. So temperature affects. To convert solid into liquid, liquid into vapors. Okay. So can matter change its state? Yes. Can matter change its state? Yes. It can change based on two factors. One is temperature factor. Second one is pressure factor. Okay. Effects on temperature. Effects on pressure. Effects on temperature: solid converted to liquid, liquid converted to vapors. That is only melting, boiling, and whatever to require for melting or boiling, minimum heat energy, that is we are calling latent heat. About latent heat given here, latent heat of fusion to make it convert 1 kg solid into liquid, that is we are calling latent heat of fusion. Same way, the energy required, heat energy required to convert 1 kg of liquid into vapors, that is we call latent heat of vaporization. And one small graph also are there. Yes, through this graph we are going to discuss about latent heat. See here, initially solid state exists at below 0 degree Celsius. That is we are calling, that is only just we are discussing with ice cube. So this is ice cube. We are giving heat, but we not notice any rising temperature in the thermometer. That is we call latent heat. Once all the molecules get equal heat, it reaches to 0 degree Celsius. That is we are calling melting point. At that time, at 0 degree Celsius, we notice that this ice solid converting into liquid. So while converting into liquid, there is no temperature rising in the thermometer. The temperature is melting point constant. Next, after converting into liquid, this is phase transition, solid to liquid. solid to liquid. Temperature is constant here, 0 degree Celsius. Melting point. This area we are calling melting. At what temperature? That is we are calling melting point. After converting into liquid, again we are giving heat to that. Again we are giving heat to that. Every molecule absorbing heat, but we never notice in the thermometer what heat is increasing. This is all hidden heat, latent heat. Once all the molecules get 100 degrees Celsius, there again we are noticing it's all liquid. Liquid molecules absorbing heat, and every surface molecule got equal heat. Overall, all the molecules, that is 100 degrees Celsius. At the time, 100 degrees Celsius. When it reached to 100 degrees Celsius, at the time, the liquid started to vapor. So here, this is phase transition, liquid to vapor, liquid to vapor. So this constant temperature we are calling boiling, boiling. So that vapors. After that, how much we are giving heat also? The temperature is constant. The liquid converting into vapors continuously. Okay, this is we used to call graph based on latent heat. On x-axis, heat is observing. On y-axis, temperature rising. So this area, this rising area, heat is transferring, but temperature is not showing the thermometer. This is the latent heat. Once reached every molecule 0 degree Celsius, ice cube molecules, then we notice the temperature rising in thermometer, that is 0 degree Celsius, that is we are calling melting. At the time, that ice cube converting into liquid. Until convert all molecules into liquid, it is constant. Temperature is constant. After converting into liquid, still we are continuously giving heat. It is absorbing heat. Again, it is rising, latent heat, but it is not noticed in the thermometer. Like that, every liquid molecules are getting 100 degrees Celsius, then we notice in the thermometer the temperature remains constant until liquid converting into vapors. That particular point we are calling boiling point. That particular process we are calling boiling process. Liquid converted to vapor. Okay, this all vapors. This is the graph. Chances to ask for 1 amperes. Chances to ask for 1 amperes. Ice. The constant, whatever we have mentioned, that is particular melting point or boiling point. At particular melting point, boiling point, temperature never change. Until convert all the molecules into another state, it remains constant temperature. Thank you, children.